In Water in the Atmosphere, we are on Chapter 2, Lesson 2, which can be found on page 46. Our big questions are, how do waves form and change, and how do waves affect the shore? My Planet Diary. Rogue waves. For hundreds of years, sailors have returned from the sea to tell of 30-meter-high waves that appeared out of nowhere. These waves, they said, plunged the largest ships into the ocean depths. For hundreds of years, these tales were taken no more seriously than the Scottish legend of the Loch Ness Monster. Ships were sunk, scientists said, in storms. Then, in 1995, an oil rig in the North Sea was struck by a rogue wave. Instruments on board measured the wave's height as 26 meters. As a result, the European Union set up a project to study these rogue waves using satellites. What the scientists found was shocking. Within 3 weeks, they tracked 10 different giant waves. Write your answers to these questions below. Why did people begin to believe in the rogue waves? And how might you track a rogue wave? Our vocabulary terms for this section are wave, wavelength, frequency, wave height, tsunami, longshore drift, rip current, and groin. Pay close attention to reading bullets and inquiries. How do waves form and change? When you watch a surfer's wave crash onto a beach, you are seeing the last step in the development of a wave. A wave is the movement of energy throughout a body of water. Water development usually begins with wind. Without the energy of wind, the surface of the ocean would be as smooth as a mirror. Here's a key point. Most waves form when winds blowing across the water's surface transmit their energy to the water. The size of the wave depends on the strength of the wind and on the length of time it blows. A gentle breeze creates small ripples on the surface of water. Stronger winds create larger waves. The size of the wave also depends on the distance over which the wind blows. Winds blowing across longer distances build up bigger waves. That's why small ponds have ripples, but the Great Lakes have waves you can surf on. Figure 1. Wave formation. Predict. Using what you've learned about wave size, circle the surfer who might ride the biggest waves. Explain your prediction. On page 48, let's look at wave characteristics. Scientists have a vocabulary to describe the characteristics of waves. The name for the highest part of the wave is the crest. The horizontal distance between crests is the wave length. Long, rolling waves with lots of space between crests have long wavelengths. Short, choppy waves have shorter wavelengths. Waves are also measured by their frequency, the number of waves that pass a point in a certain amount of time. As you can see in Figure 2, the lowest part of a wave is the trough. The vertical distance from the crest to the trough is the wave height. The energy and strength of a wave depend mainly on its wave height. In the open ocean, most waves are between 2 and 5 meters high. During storms, waves can grow much higher and more powerful. In Figure 2, there are many different types of waves, but they have similar characteristics. Identify, find and label wavelengths, wave height, crest, and the troughs on the diagram. Hint, one diagram is started. Compare and contrast. How does the frequency of the waves compare in the two diagrams? Time to apply it. Conditions at sea are constantly changing. Use the scientific vocabulary you learned above to describe the conditions at the sea in the photo. Looks like a bad storm. And 2. Form operational definitions. Write your own definition for one of the scientific terms you used above. Wave energy on page 49. Waves may appear to carry water towards shore, but water doesn't actually move forward in deep water. If it did, ocean water would eventually pile up on the coasts of every continent. The energy of the waves moves towards the shore, but the water itself remains in place. You can test this by floating a cork in a bowl of water. Use a spoon to make a wave in the bowl. As the wave passes, the cork lurches forward a little, then it bobs backwards. It ends up in almost the same spot where it started. Water motion. What happens to water as waves travel along? Notice in Figure 3 that as a wave passes, water particles move in a circular path. They swing forward and down with the energy of the wave, then back up to their original position. Deeper water particles move in smaller circles than those near the surface. At a depth equal to about 1/2 the wavelength, water particles are not affected by the surface wave. Let's look at Figure 3. Water motion. The diagram shows how the energy of a passing wave affects water particles. Apply concepts. Read the text and then complete the activity. Identify and label one wavelength on the diagram. Number 2, add circular arrows to the diagram as shown to indicate what happens to particle motion between the ocean surface and the floor. And number 3, how does a passing wave affect the submarine? What about the raft? Now challenge yourself. At what depth does particle motion stop? Indicate your answer on the diagram. On page 50, we'll look at breakers. The white-capped waves that crash onto the shore are often called breakers. In deep water, these waves travel as long, low waves called swells. As the waves approach the shore, the water becomes shallower. The bottoms of the waves begin to touch the sloping ocean floor. Friction between the ocean floor and the water causes the waves to slow down. As the speed of the waves decrease, their shape changes. Near the shore, wave height increases and wavelength decreases. When a wave reaches a certain height, the crest of the wave topples. The wave breaks onto the shore, forming surf. As the wave breaks, it continues to move forward. At first, the breaker surges up the beach, but gravity soon slows it down, eventually stopping it. The water that has rushed up to the beach then flows back out to sea. Have you ever stood at the water's edge and felt the pull of the water rushing back out to the ocean? This pull, often called an undertow, carries shells, seaweed, and sand away from the beach. A strong undertow can be dangerous to swimmers. Relating cause and effect. Read the text, then underline the cause of breakers and circle the effect. Looking at Figure 4, breakers. After you read about breakers, do the activity to show how waves change shape as they get closer to the shore. Interpret diagrams. Shade in one drawing in each column to show the sequence of how a wave forms. And summarize. How does a wave change as it approaches the shore? Tsunami. So far, you've been reading about waves that are caused by the wind, but another kind of wave forms far below the ocean surface. This type of wave is called a tsunami. A tsunami is usually caused by an earthquake beneath the ocean floor. The ocean floor's abrupt movement sends pulses of energy through the water, shown in the diagram below. Despite the huge amount of energy a tsunami carries, people on a ship at sea may not even realize a tsunami is passing. How is this possible? A tsunami in deep water may have a wavelength of 200 kilometers or more, but a wave height of less than a meter. When the tsunami reaches shallow water near the coast, friction with the ocean floor causes the long wavelength to decrease suddenly. The wave height increases as the water piles up. Some tsunamis have reached heights of 20 meters or more, taller than a 5-story building. Tsunamis are most common in the Pacific Ocean, often striking Alaska, Hawaii, and Japan. In response, nations in the Pacific have developed a warning system which can alert them if a tsunami forms. But not all tsunamis occur in the Pacific Ocean. On December 26, 2004, a major earthquake in the Indian Ocean caused tremendous tsunamis that hit 11 nations. Tragically, these tsunamis took the lives of more than 230,000 people. Several nations are now developing a warning system for the Indian Ocean. Tsunami. Communicate. Use the diagram below showing how a tsunami forms to help you develop a tsunami warning system. Include how you would warn people living in remote areas. Here you can see the destruction of the 2004 tsunami. Assess your understanding. Do you get it? Now I know that waves change as they approach the shore because, and fill in the blank.